Assalamualaikum friends, how are you? Now I'm going to share the last topic, that is classification of field, and we have studied class 1 field yesterday. So now we study class 2 field and then class 3 field. So let's start with it. Classification of field. So we have studied class 2 field. जैसा कि मैंने आपको कल बताया था कि हमें एक वेक्टर फील्ड पहले सेलेक्ट करनी पड़ती है और उस वेक्टर फील्ड को हम क्लास 2 फील्ड मान लेते हैं। तो यहाँ पर भी हमने एक वेक्टर फील्ड ले लेनी है। जैसे मैंने यहाँ पर एफ ऑफ आर को लिया हुआ है और हमने कह दिया है कि ये क्लास 2 फील्ड है। हाउ यू कैन से दैट दिस इज क्लास 2 फील्ड? अब उसके लिए ये ज़रूरी है, इट इज़ वेरी इंपॉर्टेंट फॉर दिस, दैट डाइवर्जेंस ऑफ दैट वेक्टर फील्ड इज़ नॉट इक्वल टू ज़ीरो एंड कर्ल ऑफ द वेक्टर फील्ड मस्ट बी इक्वल टू ज़ीरो. सो सेम द केस विद दिस क्लास 2 फील्ड. जैसा कि मैंने कल आपको बताया कि हम इस वेक्टर फील्ड को, जो एफ ऑफ आर है, इस वेक्टर फील्ड को हम डाइवर्जेंस और नेगेटिव ग्रेडियंट ऑफ स्केलर फील्ड हम लिख सकते हैं. तो मैंने यहाँ पर बिल्कुल क्लास 2 फील्ड को भी वैसे ही नेगेटिव ग्रेडियंट ऑफ स्केलर फील्ड लिख दिया है. अब अगर मैं इसको यहाँ पर सब्स्टिट्यूट करूँ इस इक्वेशन में, जो कि आपको यहाँ पर नज़र आ रही होगी, डेल डॉट एफ ऑफ आर इज़ नॉट इक्वल टू ज़ीरो. अगर इसमें मैं सब्स्टिट्यूट करूँ इसको, ओके, नाउ आई एम गोइंग टू सब्स्टिट्यूट this f of r is equal to negative gradient of f of r in this equation. Del dot divergence of f of r is not equal to 0. When I substitute this in this equation, I will get this. Let's say this is equation number 1. Okay, when I substitute here, I will get the same result on the left hand side as we got in class 1 field, and that is the del square f of r. But that was equal to 0. This is not equal to 0. So we will say that this is Poisson scalar equation, and that was Laplace scalar equation. When this is equal to 0, it will be Laplace scalar equation. But if it is not equal to 0, then it will be Poisson scalar equation. Okay, if someone say that how you will get the class 2 field, then you have to solve the Poisson equation. When you solve the Poisson equation, you will get the class 2 field. Okay, so by using or by solving the Poisson scalar equation, you can get the class 2 field. Example of the class 2 field is a static electric field in the charged region. Okay, static electric field in charged region is the example of class 2 field. Okay, now I am going to tell you about the class 3 field. Class 3 field. Class 3 field. We have to consider a vector field, that is f of r, and then we say that this is class 3 field. But how we say that it is class 3 field? Why we didn't say that it is class 2 field or it is class 1 field? How we can say that f of r is the class 3 field? If we take divergence of that vector field and it gives us 0 answer, and when we take the curl of that vector field, that class 3 vector field, its curl will not equal to 0, then it will be class 3 field. In this equation, you can say that we got divergence of electric field not equal to 0 and curl of the class 2 vector field is equal to 0. But here it is reverse. You can see here. Here f of I can be expressed in terms of the curl of another vector field. हमने बिल्कुल वैसे ही जैसे हमने पिछले दो फील्ड में हमने एफ ऑफ आर को किससे डिनोट किया था. लेट मी रिमूव दिस. ओके, remove this one. Okay, now I can write here this one. Okay, you can see here that in class 1 and class 2 field we say that f of r is equal to negative gradient of f of r. But here you can see that we say that f of r is the curl of the vector field, and this vector field, that is v of r, is also a class 3 field. It also belongs to the class 3. Okay, now substitute this value in equation this one. Curl of the vector field, class 3 vector field, is not equal to 0. When I substitute this in this equation, I will get this one. Now I have to apply a very famous vector identity, that is, sorry, I forgot to write this here, but I can, okay, curl of the curl of vector field is equal to this gradient of the divergence of that vector field minus del square v of r is not equal to 0. But for class 3 field, divergence of vector field is equal to 0, as we have studied here, and this v of r is belonging to this f of r, mean class 3 field, so it will be 0, and this is the equation. Now this is Poisson vector equation. Why we call it vector equation? Because we have studied last time two equations. First is Laplacian scalar equation and the other one is Poisson scalar equation. Okay, look, why we call it Poisson vector equation? Because you can see here, this is a vector quantity. I just call it here that v of r is class 3 field, so it will be a vector field. Magnetic field in the current region, and magnetic vector potential is the example of class 3 field. Thank you for watching. If you like this video, subscribe to my channel and share this. Okay, Allah Hafiz.